Good morning. Today we will talk about properties of logarithms. So let me first remind you the properties of logarithms we have talked about when we defined logarithmic function, and then we will learn three more properties today, and we will start solving problems using these properties of logarithmic functions. Remember last time we talked about two spatial logarithmic functions. When the base is 10, we called it common log. And I said in these situations, we write only log and we do not write any base. And that by default would be understood as log base 10. Whereas if the base is that spatial number e, where e is the irrational number between 2 and 3, we call it natural log. And in this situation, as we have discussed last times, the convention is to write ln. So if I write ln x, it's understood that the base is e. We talked about properties that log of b with respect to base b is 1. Hence in common log, log of 10 with respect to base 10 is 1. In natural log, ln of e with respect to base e is 1. We said log of 1 irrespective of the base is 0. So log of 1 to the base b is 0. Log of 1 in common log to the base 10 is 0. Log of 1 with respect to e base or natural log of 1 is equal to 0. We talked about a bifold inverse property. That is log of b to the power x to the base b is x, or b to the power log of b to the power x to the base b is x. In fact, I want to write this property in a little different way. I want to write it as log of x to the base b when raised to the power of b is equal to x. So if I want to understand these inverse properties in common log, I will say log of 10 to the power x, because the base is 10, is x, or 10 to the power log of x to the base 10 is x. Similarly, in natural log of e to the power x is x, and e to the power natural log of x is equal to x. The three properties that we will talk about today are called product rule, quotient rule, and power rule. If both m and n are greater than 0, then log of the product of m and n will be distributed as log of the first one, m, plus log of the second one, n. If you have a quotient, m over n, log of the quotient m over n will be log of the top minus log of the bottom. If you have log of m to the power p, then you can write this p in front. We will work out the following problems. The first set of 4 problems is asking us to combine or expand the logarithmic forms. If I look at the first one, I have 3 logarithmic terms. So I want to make it 1 by combining. So what I do? I say log of b to the base a plus the power c, I write it in place of power of d. So I say log of d to the base a, and in place of the power of d, I write c. And minus log of s to the power r to the base a. The first two, I can combine them using the product rule and say that this is log of b times d to the power c to the base a minus log of s to the power r to the base a. And then I can combine them using the quotient rule. So log of the first one, b times d to the power c, is on the top. The second one, which is s to the power r, is on the bottom, and the base is a. And that will be 1 logarithmic term, will be my final answer after the combination of 3 logarithmic terms. Let's do b. Problem number b is asking you to combine, because if you have more than 1 logarithmic term, you want to write one of them. Recall, all the bases are 10. That's why I'm not writing anything. So the first one, write as log x squared, as the power goes to the power. minus, I say log of x squared plus 1, that's the input, whole to the power 1/5. That's again, the constant goes to the power. 3 goes to the power, so I write it as log of x minus 1 whole to the power 3. Now see, the first one and the third one are positive. So I combine them using the product rule, and I say that this is log of the first one times the input of the last one, which is x minus 1 whole to the power 3. I still have the minus term, log of x squared plus 1 whole to the power 1/5. Because of the minus, it reminds me of quotient rule. So I'm going to go ahead and say that this is log of the first one on the top, so x squared times x minus 1 whole to the power 3 all over x squared plus 1 whole to the power 1/5. I have combined all of the logarithmic terms, and I got my final answer. The next one, again, I have more than one logarithmic terms, and I want to combine them. So because I do not have any constant multipliers other than 1, I will go ahead and say that the first two are positive, so I can combine them using the product rule, and I will say log of the first one times the second one. Now look at the next pair of terms. The next pair are both negative. What if I factor out the minus? And I get log of 2 plus log of x plus 8. So all of a sudden, I have a plus between two logs, which is also a product rule. So the first term you don't change, you keep it log of x times x squared minus 64, whereas the second one, you multiply. You say log of 2 times x plus 8. Now I have a minus between two logs, so that will be the quotient rule. I will say log of x times x squared minus 64 all over 2 times x plus 8. And that should be the ultimate combination of the three logarithmic terms, giving me the final answer for this problem. When I look at the fourth one I have only one logarithmic term. So I want to expand and make as many out of it. The first thing, I have a quotient. So use the quotient rule. You say log of x times x squared plus 7, or log of the top, minus log of square root of x squared minus 7, which is the bottom. Now remember, this is a product of two terms, so use the product rule. It's log of x plus log of x squared plus 7. Whereas, if you think of the third term, the square root is actually a power. It is the 1/2 power of the x squared minus 7 term. So using power rule, now I can bring this power in front and call it log of x plus log of x squared plus 7 minus the power comes in front, log of x squared minus 7. And that will be all the expansion that I can do and will be my final answer to the question. If I look at the fifth example, I see there is again only one logarithmic term. So I am asked to expand it. Again, you start with a quotient. So you write it as log of the top minus log of the bottom. The power 2 comes in front, so I write it as 2 log a. Now I have to be a little careful. This is a product rule, so I will get out of this 1 log 2 terms. Because there is a minus in front, these new 2 terms, I will put them inside parentheses. So I will write it as log of b to the power 8 plus log of square root of c. It's the first one plus the log of the second one. Now play with the powers. So you get 2 log of a minus log of b to the power 8 minus log of c to the power 1/2. Again, I'm changing the square root as a power 1/2. Also, I distributed the minus. So I get 2 log of a minus 8 log of b. What did I do? I used the power rule to bring the 8 in front. Minus 1/2 log of c. And that's all I can do with this logarithmic function. So I have done the proper expansion and I got the final answer to my question. The sixth one, you have one logarithmic expression, so it requires expansion. I cannot start with quotient rule on this one because I have this outside square root, so change it to power first. So this is log of x to the power 7 plus 5 all over x to the power 6 plus 10 times x to the power 4 minus 3 times 9. And think about the square root being the power 1/2. And now think about what you do with the power. Well, it comes to the front. Then you get 1/2 log of x to the power 7 plus 5 over x to the power 6 plus 10 times x to the power 4 minus 3 to the power 9. Now I will use the quotient rule. So I will get 1/2. Again, I will get multiple terms. So it is ideal that you put them inside the bracket or parenthesis. You call it log of the top, x to the power 7 plus 5. Quotient, so minus log of the bottom, which is x to the power 6 plus 10 times x to the power 4 minus 3 whole to the power 9. And then I close my bracket. So I write it as 1/2 log of x to the power 7 plus 5. Remember, I cannot do anything with this thing. But the next pair of terms, I can use product rule and get multiple terms out of it. So I can get log of the first one, which is x to the power 6 plus 10. Product rule, so you will get plus log of the second term, which is x to the power 4 minus 3 whole to the power 9. X to the power 4 minus 3 whole to the power 9. And then I closed my bracket and one more time. Finally, I will do a bunch of distributions. So I will say this is 1/2 times log of x to the power 7 plus 5 minus getting distributed gives you log of x to the power 6 plus 10 minus log of x to the power 4 minus 3 whole to the power 9. And then I see I can bring the power 9 that I see here in front using the power rule. So I will write it as 1/2 log of x to the power 7 plus 5 minus log of x to the power 6 plus 10 minus 9 times log of x to the power 4 minus 3. Finally, one more distribution, the 1/2. So call it 1/2 log of x to the power 7 plus 5 minus 1/2 log of x to the power 6 plus 10 and minus 9 over 2 log of x to the power 4 minus 3. And that's all I can do. And hence, I got my final answer for the expansion of this one logarithmic term. Let's see what else we can do. We'll go to our next page. This is talking about the base change formula. So if you have log of m to the base b, you can either write it as log of m to the base 10 over log of b to the base 10. And because they're common log, I did not write the bases. Or I can go ahead and say that this is natural log of m over natural log of b. They're precisely the same thing. So idea is, if you have any logarithmic term, log of m to the base b, you can always write it as log of m over log of b. And it doesn't matter what base you choose. I can choose anything. I can choose any base as long as the bases are the same on top and bottom, and the base is not equal to 0, not equal to 1, and it is strictly greater than 0. I'm good. Why are we going to use that to help us? If I want to know log of 16 to the base 12, how much is that quantity, and round it to 4 decimal places? How do I do that? Well, write it as log of 16 with respect to base 10 over log of 12 with respect to base 10. In your calculator, you can compute both of these values. So let's see that. And remember, we are rounding to 4 decimal places. So this is our calculator. The first screen doesn't show you the log button. No, it does show you the log button. So I'm going to go ahead and I will say that 16 on top, so I will do log of 16 on top. So log of 16 on top, that will be this value, and I will divide it by log of, the bottom is 12, and that will be my answer. When rounded to 4 decimal places, because the 5th decimal place is 1, fifth decimal place is 7, I'm so sorry. And that's greater than 5, I add 1 to the previous decimal place and it becomes 1.1158. So the answer to this question is 1.1158. The next question is 3 logarithmic terms, and I'm going to use the base change formula in order to simplify this. How do I write it? I write it as log of 8 over log of 7 by the base change formula. The next one I write it as log of 11 over log of 8, again by the base change formula. And the last one I write it as log of 7 over log of 11. And see, I don't have to calculate them in the calculator. Why? If you look at the top and bottom, you have the same factors. Log of 8 cancels with log of 8, log of 7 cancels with log of 7, log of 11 cancels with log of 11. So your ultimate answer is 1. Let's check whether the following examples are true or false. If I have the left hand side given to me as x log 10 to the power x, I can bring this power x in front and I will get x is already there, that's this x. This power x will come to the front, so I will get x times log of 10. Remember, log of 10 is log of 10 to the base 10, so that much is 1. So I get x times 1, which is x squared, and that is the right hand side. So the first expression is true. How about the second one? Well, I see a subtraction between two logs, so I can write it as log of x plus 8 over 2x using the quotient rule, and that's the left hand side. But see, this is not equal to the right hand side. The right hand side is log of x plus 8 divided by log of 2x. So I distributed the log, which I cannot do in quotient rule. So I will say that this expression is a false expression, and that would complete the true-false arguments. Again, we're going to identify some of the values, and this time we're identifying these values without using a calculator. So I have log of 10 to the base 2 minus log of 30 to the base 2 plus log of 96 to the base 2. So let's see how we can use quotient rule on the first two. I will get log of 10 over 30, the first over the second, to the base 2. I still have log of 96 to the base 2. So I get log of 1/3. This plus will give you a product rule. So you multiply 96 to the base 2. And then 3 divides 96 gives you a 32. So log of 32 to the base 2. What power of 2 is 32? Well, if you multiply 2 for 5 times, you get 32. So 32 is 2 to the power 5. And then remember the inverse rule. The inside is exponential, outside is logarithmic. Both of them has the base of 2. So your answer is just the input 5. Answers to your question. The next example is log of 10 to the power 100. Well, think about exponential function with base 10 followed by logarithmic function with base 10. So I just get the input, which is 100. That's the power. Now log of 100 is log of 10 squared. Do not forget, this is exponential function with base 10, logarithmic function with base 10. Both of them are 10, so they cancel, and you get the input as the power, which is 2. Similar, if you have common log, then you can answer it using inverse rule. So how about natural log? Again, you have exponential function with base e, natural log function with base e, cancel them. You get the outside natural log and the input, which is e to the power 300. That's the entire thing is the power. Exponential with base e, natural log is logarithmic with base e, cancel, you get 300 as your final answer. Even more, I want to identify how much will be log of 10 to the base b, log of 10 over 7 to the base b, given log of 2 to the base b, log of 5 to the base b, log of 7 to the base b. See what I can do. I first write log of 10 over 7 to the base b equal to, using the quotient rule, log of 10 to the base b minus log of 7 to the base b. What is 10? 10 is 2 times 5. And why I broke it in 2 and 5? Because those are the values given to me. So I will do product rule now on 2 times 5. So I will get log of the first one plus log of the second one, both with respect to base b, and minus log of 7 to the base b was already there. And you know all three of these values. So the first one, log of 2 to the base b is 0.328. I add log of 5 to the base b, which is 0.779. And then I subtract log of 7 to the base b, which is 1.025. So let's add the first two. 8 plus 9 is 17. 1 carries on. 2 plus 1 is 3 plus 7 is 10. 1 carries on. 3 plus 1 is 4 plus 7 is 11. So 1.107 minus 1.025. I subtract. 7 minus 5 is 2. 10 minus 2 is 8. 0 minus 0 is 0. 1 minus 1 is 0. So it's 0.082. Answers my question. We have a couple more of these property problems. So this one is saying, in each part, find the value of x in the simplest form. And I will not be using calculator. So for the first one, you will write 1 over 9 as a power of 3. So first write it as log 9 to the power negative 1 to the base 3. Then remember 9 is 3 squared. So write it as log of 3 squared whole to the power negative 1 to the base 3. If you have power of power, you multiply the powers. So you get log of 3 to the power negative 2 to the base 3, which is a negative 2. So that is your simplest value for x. Similarly, the next one, I will write it as log of 10 to the power 1/3 to the base 10. So exponential with base 10, logarithmic with base 10, cancel. You get the input power, which is 1/3, as the simplest value for x. Log of 0.001. So write it as a fraction first. Write it as log of 1 over 1000. Why 1000? Well, there are 3 decimal places, so I need 3 zeros after 1 to make it fraction, and the base is 10. Then I write it as log of 1000 to the power negative 1 to the base 10. Well, that is log of 10 to the power 3 whole to the power negative 1 to the base 10. How do I know it's 10 to the power 3? Again, count the zeros. There are 3 of them. So 10 to the power 3. Power of power, you multiply the powers. You get log of 10 to the power negative 3 to the base 10. So your answer is negative 3, as it is an exponential function base 10, logarithmic function base 10. They will cancel each other by the inverse rule, and the simplest value of x will be negative 3. Inverse rule in other format. So this one, you have a natural log of 2 to the base e, and there is a multiplier 2. So what I do first, I write it as e to the power 2 times natural log of 2, then bring this 2 constant as a power of 2. It becomes e to the power natural log of 2 squared. Now see, log with base e, exponential with base e, cancel them. You get the power 2 squared, which is 4. That's the simplest value for this expression. One more time. You have 10 to the power 5, log of 5 to the base 10. Bring this constant to the power of the input. You get 10 to the power log of 5 to the power 5 to the base 10. You have log with base 10, exponential with base 10, cancel. You get 5 to the power 5, which if you recall was 3125, and that should be the simplest answer for this question. Log of 27 to the power 10 to the base 3. So write 27 as a power of 3. That's 3 to the power 3. I have this external power 10 with the base 3. Power of power, multiply the powers. So you get 3 to the power 30 to the base 3. And then exponential with base 3, log with base 3, cancel each other. You get the power input of 30 as the simplest value to the problem. Like the last problem in the last page, now I have natural log of a equal to 2, natural log of b equal to 3, and natural log of c equal to 5. And I want to simplify the results for the following logarithmic expressions. So I will use the properties of log. So first I write natural log of a to the power negative 4 minus natural log of b to the power negative 4, c squared, that's quotient rule. That is equal to natural log of a to the power negative 4. Remember, this is product rule, so put them inside parentheses. Write it that as natural log of b to the power negative 4 plus natural log of c squared. distribute the minus. You get natural log of a to the power negative 4 minus natural log of b to the power negative 4 minus natural log of c squared. Now use the power rule. The power comes in the front as a constant. So minus 4 times natural log of a minus times minus 4 times natural log of b, and then finally I get the 2 in front, so minus 2 natural log of c. Why I did all these things? Because I know the values for natural log of a, which is 2. I know the value for natural log of b, which is 3. And I know the value for natural log of c, which is 5. So I get negative 8 plus 12 minus 10. So when I combine them, I get negative 8 plus 12 equal to 4 minus 10 equal to negative 6. And that is the simplest answer to the question. Let's see what else we have. Same problem using rules of logarithm. So first write it as natural log b to the power 4, c to the power 4, a to the power negative 3, whole to the power 1/2. That's the square root. Bring it in front. 1/2 natural log of b to the power 4, c to the power 4, a to the power negative 3. And this is a repeated product rule. So I will keep all these terms inside parentheses. So we'll write 1/2 outside natural log of b to the power 4 plus natural log of c to the power 4 plus natural log of a to the power negative 3. That should equal to, now you bring the powers in front, so it will be natural log of b with the 4 in front. You still are inside the parenthesis. And then the next one will be plus 4 natural log of c. And then you will have plus negative 3 is the power natural log of a. Then you distribute the power 1 at the constant 1/2. So you get 4 over 2 natural log of b plus 4 over 2 natural log of c minus 3 over 2 natural log of a. And I know all these values. Natural log of b is 3. So I get to say 2. 4 over 2 is 2. And times 3. Natural log of c is 5. So I get 2 times 5. Minus 3 over 2. Natural log of a is 2. So you get 6 plus 10 minus 3. So that's positive 13. Answers your question. The next problem, do not make the mistake of thinking of quotient rule. You just simplify the natural log on top and natural log of bottom. And the first one is by product rule. So natural log of a to the power negative 1 plus natural log of b to the power 3. On the bottom, I use the power rule first. So minus 3 times natural log of bc. Now on the top, I use power rule. So minus 1 natural log of a plus 3 natural log of b. Whereas on the bottom, I use product rule. But I keep them inside parentheses. So I say natural log of b plus natural log of c. So I get minus natural log of a. I just don't want to write that constant 1. Plus 3 natural log of b over minus 3 natural log of b plus actually minus 3 natural log of c. And then you input the values that you know. Natural log of a is 2, so I get minus 2 plus 3 times natural log of b is 3 over minus 3 times 3 again, and natural log of c is 5. So let's simplify. I get negative 2 plus 9 over negative 9 minus 15. Negative 2 plus 9 is positive 7 over negative 24. And that's my final answer. 7 over negative 24. The last problem in this handout is one more instance of using the values of natural log of a, b, and c. So I use product rule. I get negative 2 times natural log of c. This one is not a power of the argument. It is the power of the logarithmic term. So don't mistake for using the power rule. Rather, use the quotient rule. Natural log of a, the top, minus natural log of b to the power negative 2, the bottom. And that is inside parenthesis to the power 1. So I get minus 2 natural log of c, natural log of a. Think about this negative 2 and bringing it in front. Negative times negative will make it positive 2 natural log of b to the power 1. Now you input your known values. Minus 2 times 5 is natural log of c, times natural log of a is 2, plus 2 times natural log of b is 3, whole to the power 1. So I get minus 10 times 2 plus 6 to the power 1, which is minus 10 times 8 to the power 1. 8 to the power 1 is just 8, so negative 10 times 8 is equal to negative 18. So we have seen bunch of problems involving the properties of logarithmic function today. In our next class, we will be willing to use these properties in order to solve equations involving exponential and logarithmic function. If you have any question, please do not hesitate to email me. I will get back to you as soon as I can.